out there. Hope you're having a great conference. Really excited to talk to you today. Want to thank the folks at GitCon for putting this together. They've been amazing virtual hosts, and I think they've pulled together some world-class content. I'll start by giving a little introduction about who I am. My name is Mike Donovan. I'm a VP of product at Docker, and my background is actually much more in engineering than product management. So I spent a better part of my career, 15 plus years, as a full stack engineer. My academic background is computer science. And throughout that career, I found myself really gravitating towards product management, helping users solve their problems. But my focus in my product management career has really always been about building great developer tools. Maybe it's because I'm a little selfish and I like to build tools for myself. But I've been having a great time doing it in my career, especially at Docker. When I'm not doing anything in product management or dev tools, you can probably find me swimming, biking, and running, usually in that order. Love to run triathlons. It's become a hobby of mine. If any of you are interested in discussing triathlons, would love to do that as well. Today, I'm here to talk to you about how we at Docker are driving developer empowerment in this new GenAI era, and we're doing so through the tools and ecosystem uh, surrounding Docker. So let's get right into it. It's probably no surprise that my talk is focused on GenAI, but let's really ground ourselves in why that is. We're seeing record levels of investment being made to build out this GenAI marketplace. Tons of money is going into it. And the majority of that investment so far has been in infrastructure. Really no surprise on that. But what we're seeing is a quick shift towards application development. Now, at Docker, we obviously have a pretty special focus on container technology and its impact on application development. And something that's abundantly clear to us is that containers and the ecosystem around containers are playing a critical role in the development of GenAI applications. All kinds of developers are using containers to package, distribute, and scale GenAI applications in a secure and consistent way. And like major technology shifts of the past, there's a lot of these changing happenings which create both challenges as well as opportunities. And one such shift from this has been the specialization happening in engineering. I think it's helpful to look at this across the spectrum, from data science on one end to application development on the other. Now, for many years, the development of AI applications really required a team of ML researchers, data scientists, machine learning engineers, and then it also meant you had to throw that output over the wall to a team of full stack engineers who would eventually productize it. Now, I personally remember being on many teams and making a lot of decisions about big bets we would make for data science projects, where we would have an entire team of data scientists go off for 6 months at a time, not knowing exactly what we would get on the other side of it, but knowing it would be worth it. But then whenever that output came, it would be thrown over the wall to another team who would struggle to prioritize it in their backlog. And when we did, it would have a great impact, but the time to value was always so long. And back then, before ChatGPT really shocked the world, I used to believe that the future was really all about data scientists becoming more like full stack engineers, learning different skills around coding and design, product management skills along the way. But it seems like I was really wrong, because we've started to see a democratization of sorts, right? Where there's this new specialization of engineering being created that is dubbed AI engineering. Now, these engineers have a lot of the same full stack skills, but not really that many of the data science skills. It's not necessary because of the technologies that are out there, but they are becoming experts in the tools, the frameworks, and the infrastructure needed to build those GenAI applications. A comparison I love to make is one to the rise of mobile app development. Here on the screen depicted is the number of apps available in the App Store over, I think, a 10-year period, really that reflects the rise of the mobile app development market. More apps meant more development was happening. There's a lot throughout that period. Not only did the number of apps grow, the number of developers grow, but there were a lot of other changes that happened and things that happened over the course of that timeline that were extremely difficult to predict early on. I mean, nobody could really predict what would happen, but we saw so many changes happen, right? We saw big companies fail to take advantage of massive trends in front of them. I'm sure we all remember Microsoft and Bill Gates saying that nobody's going to walk around with a computer in their pocket. I think they were wrong about that. We saw the proliferation of different devices. I'm sure some of you remember the Amazon Fire Phone. We saw the battle between closed and open ecosystems, the Apple versus Android. We saw new programming languages get invented. We saw the creation of hundreds of new operating systems be created, all kind of founded off of the Android open system. And most importantly, we saw brand new user applications built that we would have never dreamed of 10 years ago. And that's really what fueled the application development careers all over the place and the specialization in mobile app development. And the point here is really to reflect on this trend in relation to the trend we're seeing now in GenAI development, because we're in the early innings of this transformation, right? ChatGPT only came out a little over 2 years ago. And so if you think about this in comparison to the mobile app development trend, we're really early on. But I think one thing's for sure is that every transformation that happens more quickly than the last. Now, one of the things we're finding at Docker as we work with our users and our customers is that there are still some constants in the GenAI development world. And those constants are founded in the key areas causing pain for engineering organizations. Many of these pains are the same pains that engineering organizations have experienced in previous waves of technology. Some of these might even sound familiar to many of you that you deal with all the time. These pains are around creating a high quality developer experience, right? Which, if you do that, improves your velocity, your rate of innovation, and really important, avoid the toil that's involved in a poor developer experience. The next pain point is around developer choice and creating efficient workflows and processes and tech stacks without creating too much tool sprawl, right? Which then becomes really impossible to manage. Then the final area of pain really is about risk management, right? And this could be risk management from a quality perspective as well as from a security perspective. And securing your supply chain is a really big challenge for organizations, especially in the GenAI era. Now, our focus at Docker, as we look to help mitigate those pain points, is in the inner loop, right? We call this the inner loop that we help developers in shipping superior code. Now, by inner loop, this really means all the activities that a development team does to build, test, and push code. And we believe that by focusing on improving the inner loop, we can positively impact those areas of pain we just described. So our focus is to help empower teams in this new era of GenAI development. And we're really finding some challenges and opportunities within the inner loop that we can impact. And this is what we'll focus on for the remainder of the session now. There's four main areas of challenges and opportunities that we're going to dive into. The first challenge is around discovery, right? And this has to do with the challenge that developers across the world face by identifying the right tool to use in a crowded landscape of tools, frameworks, and technologies to choose from that's really growing at a really fast pace in as new technologies are being created in the GenAI era. The next challenge we'll talk about is the steep learning curve that developers face as they try to use these new tools, right? They're not only new tools and technologies, but they're new entire concepts that are introduced, and they're being introduced rapidly as research grows. And it's difficult to really understand for many of the engineers. It's not all challenges, though. There's some opportunities that are created. First opportunity we'll talk about is the creation of co-pilot technologies or assistants that can really help developers innovate at a faster clip and improve their daily lives. And then the last opportunity we'll talk about are agentic workflows. And this is really a new way to think about how to build applications in a non-deterministic way that I think can really shape architectures for years to come. So let's dive into each of these. First challenge we'll cover is discovery. Now, this isn't exactly a new phenomenon that there's a crowded landscape of tools for developers to choose from. But I do think that GenAI is amplifying this issue with all the new categories of tools being created, all the new companies that are emerging that are trying to solve problems in these categories. Old companies building new technologies, net new technologies being created and invested in, all of them fighting to win over developers to adopt their tool. And each of these tools, not only are there a lot of them, but they all come with a learning curve because it's a new type of technology to learn about. I mean, a great example is the idea of a RAG application, right? A RAG was something you washed your dishes with a year ago, but now it's an entire new way to build applications that developers are having to learn about. Now, thankfully, helping developers solve this type of challenge isn't exactly new for Docker, right? We've been helping developers sift through the vast landscape of options for years through Docker Hub, which is the world's largest container registry. And we can already see the impact we're having in the development world. So on the screen here, you can see the massive growth of developers pulling images from Docker Hub. And what that means is they're downloading images from Docker Hub when we say pull. And specifically, we're looking at the AI ML category of images available on Docker Hub. In this category alone, we're seeing over 130% growth year over year in the amount of downloads that are happening for AI ML images. Normally, we'll see it for other types of categories like databases or orchestration tools or messaging queues. We see like a 20 to 30% growth rate, very healthy, and that's usually a reflection of just the rate of adoption of container technology. But for AI and ML, we're seeing this explosion in growth. And I think that clearly shows we're serving a need in the market where developers are trying to understand the landscape and adopt the best tools. So we decided to double down on this and help even more. And so in that effort, last month, Docker Hub launched a brand new experience that we call the GenAI catalog. Now, what is this? It's a curated list of the top 30 to 40 images that you as a developer should know about when pulling and building GenAI applications. It includes everything from models, databases, orchestration tools, workflow tools, and full end-to-end developer frameworks to use. We also added support for Docker Compose files as a first-class citizen in Hub, which serve as a really great and easy way to get started with examples of full applications that depend on a lot of different frameworks and tools. You can go to hub.docker.com today and experience this right now. Love for you to go do that and love for you to hear your feedback. One of the crucial parts of the GenAI catalog I mentioned was models that are available on Docker Hub. These models are all deployable. Importantly, they're all deployable as containers, right? So it's a runnable artifact as the model. Comes with the inference API as well. We've partnered with many model publishers on this, including IBM, who've been creating the innovative Granite models, as well as Upstage and their Solar LLM models, and many others. We've been extremely excited to see how well containers work to create those optimal environments to run and scale models in a secure way. And those models available in Docker Hub serve as a standard to build that future on top of where containers continue to play an important role. The next challenge we'll talk about is the learning curve. Now, similar to the challenge with understanding a vast landscape, learning curves are also nothing new for developers. I just think GenAI applications and tools happen to be a very steep learning curve for multiple reasons. The first reason is due to the difficulty in configuring all those tools and frameworks and services to run in your local environment or in higher environments. For a lot of developers, it's the first time that they're using machine learning libraries that are maybe optimized for very particular hardware configurations. And this kind of leads to that next challenge where maximizing the applications for particular hardware requirements and optimizing them is a really difficult task for developers who haven't done it before. Many have been hardware has not been a main thing that they've thought about. And there's a lot of nuances and differences between running on NVIDIA GPUs versus AMD GPUs or Intel hardware. And ensuring your container has access to it and is optimized for running it, that can require expertise that not everybody has, really increasing that the steep learning curve. Now, how have we solved this? The first part of our solution goes back to what I mentioned before about the Docker Compose stacks available in the GenAI catalog. It's one of the main reasons why we introduced them, because it allows for the abstraction of all that complexity within the Compose file. We call these stacks because they serve as a full stack application that really helps you get started very quickly and encapsulates all the different hardware configurations. All you have to do is run Docker Compose up. The second way we're helping solve this challenge is through our Docker Desktop and NVIDIA AI Workbench integration. So this really represents a collaboration that enhances that installation experience of what it takes to get started building AI applications. Now, for those who don't know, AI Workbench is a developer tool that facilitates development, management, and collaboration across different platforms, with a particular focus on making GPU interactions straightforward. By embedding and integrating Docker Desktop more seamlessly into the AI Workbench, developers experience a smoother and more efficient setup process, installation process, and it eliminates the switching back and forth between different environments to build your application. The final part of our solution has to do with building out many more new experiences within Docker Desktop to shorten that learning curve for developers. Soon in Docker Desktop, developers will be able to explore that same GenAI catalog right within Docker Desktop without having to leave or navigate away to the web. It'll also include those Docker Compose stacks, making them even easier and simpler to run. We're going to be investing in new one-click to run experiences that abstract even more of the complexity away, with getting up and running with a GenAI model ready to use. And finally, we're going to be exploring integrations with various cloud environments that'll make it possible to experience running GenAI applications on the best hardware options available. This will be especially useful for those developer laptops that lack all the great and latest GPU capabilities. All right, so now that the challenges are behind us, let's discuss those opportunities we see being created in the era of GenAI. First one we'll talk about are co-pilots, these assistants. Now, Docker has partnered with GitHub to create an extension to the GitHub Copilot that enables some really powerful developer activity. What this allows you to do when you add the extension to GitHub Copilot allows you to easily create all the necessary Docker artifacts and understand Docker technology right within the environment that the developer's coding in. Helps you write things like Docker files, compose files, helps you assess the security risk of the container you're building. And critically, it standardizes a lot of the best practices that that only the most advanced Docker users end up learning, but now you get to speed up that learning process by encapsulating all the best practices. And what that really does is enables developers to focus on innovation instead of learning the nuances of how to write, the best and most optimal Docker file. The other impact this has is helping to rapidly containerize more and more applications, especially GenAI applications, which helps to ensure a consistent experience from one environment to the next. Now you can do a lot with the Docker extension for GitHub Copilot right within the developer's coding environment without switching tools or disrupting their flow. You can do things like initiate a conversation with the extension by easily just writing @Docker to trigger the agent. The agent's powered by the Docker documentation, which allows you to ask questions of all kinds, from as simple as what does it mean to containerize an application to something more advanced, like how do I start a container with a volume? It allows you to generate the right Docker assets for your project, helps you containerize your application very quickly, writing a Docker file for you, a Docker compose file for you, and again, using the best practices encapsulated right into the agent. And it also helps you secure your applications from the start. We've integrated the extension with Docker Scout, which is a great way to secure your container applications from the beginning and make sure you're using the most secure dependencies in your application. So I've said a lot about what this extension does. Why don't we take a look and see it in action?
So I'm on github.com and I've got a repo with a React front end, Spring backend, and a MySQL database. This repo isn't yet containerized, but Docker can help us with that. The Docker extension for GitHub Copilot is helpful for existing Docker users and folks looking to learn about containerization and get started. So let's start by asking @Docker about containerization. So I'll type @Docker, can you tell me about containerization? What are its benefits? And so it looks like it's printing out a bunch of different benefits of using containers, which is awesome. And that all sounds super useful. So let's ask the Docker extension for GitHub Copilot to containerize our app. So I'll type @Docker, can you help me containerize my app? So let's see what it did. So, okay, oh great. It generated a couple of different assets and also provided us with some explanation of what each file does. So we have a Docker file for each of our services. So we have one for our front end and one for our back end. And it looks like it also successfully detected the languages for each of our services. So, and if we click into these, we can also see that each of the files is using a multi-stage build, which helps with both optimizing things and improving the overall readability and maintenance of each file. So that's awesome. We also have a Docker compose file, which is really great because that'll help us spin up our app end-to-end in containers, which is really nice for our local development scenario. Oh, and it looks like the Docker extension for GitHub Copilot is also asking me if I want to open a PR. And so I'll say, yeah, let's open a PR. And so it looks like it opened a pull request for us with these assets. We have a nice pull request comment here, which helps us orient ourselves. And then if we click in to see the files change, we can see that it added 2 Docker files, one for our front end and one for our back end, a compose file, and a couple of Docker ignore files, which is awesome. But let's imagine that I'm new here, and let's see if Docker can tell me about how to use these files. So I'll type @Docker, how do I use these Docker files in the Docker compose YAML file? Awesome. And so, with a full integration of docs.docker.com in the Docker extension for GitHub Copilot, it's actually telling me how to build and run my application in containers. So, as a new developer, this is super, super useful. Okay, one last thing. Integrating security early and often in the development cycle is crucial, and that's precisely what Docker for GitHub Copilot will help us handle. Using the Docker extension for GitHub Copilot, we can proactively manage security issues with output powered by Docker Scout seamlessly in our Copilot chat. So let's see that in action. So I'm going to type at Docker, can you tell me if I have any vulnerabilities in my project? And using this simple prompt, we can see that I do actually have a couple of vulnerabilities to fix and instructions about continuing to use Scout in the CLI. And that's pretty much it. We saw the Docker extension for GitHub Copilot help us learn about containerization, generate Docker assets to containerize our app, teach us how to build and run Docker files and compose files, and help us find security vulnerabilities in our project. We'll be adding more capabilities in the extension over the limited public beta, so stay tuned.
I love seeing the Docker extension Copilot in action because I know how helpful it's been for so many users as one of the most popular extensions for GitHub Copilot available. Definitely recommend giving it a try if you haven't already. Would love to hear your feedback. Now on to the last area of opportunity that we see in the GenAI era. And this is one I'm personally really excited about, called agentic workflows. It's a fancy name. I'll describe what it means. This all came about from our exploration in through GenAI application development, right? And it's something we started about a year ago through the Docker GenAI Labs project. Now, what this is, it's essentially a set of blog posts and code bases, Visual Studio Code extensions, Docker Desktop extensions, and they're all exploring the boundaries of what's possible with GenAI. At the end, I'll post a link to the project so you can read more about it, right? But each mini project within this series are basically attempts to accomplish a meaningful task with GenAI. It's kind of like we go on a mission each time and see if we can have GenAI accomplish it. For this particular one we're going to walk through, the mission was focused on generating a Docker file that was useful, so that could be used without any human interaction. And to do this, we essentially were using tools and large language models to talk together to achieve this outcome. Now, most people know it's pretty easy to go and ask a large language model to generate a Docker file, or really any code for that matter. But in my experience, and I think it's definitely getting better, but in my experience, some of that code is rarely useful without a lot of heavy manipulation, especially for more nuanced tasks, like writing a Docker file for your specific application. So this is where agentic workflows came in, and we really tried to create this interaction without a human in the loop. Now, when we say the words agentic workflow, it really comes down to a fairly simple concept where you're enabling a large language model to invoke a function that you define when it should be invoked and under what context it should be invoked and what the function does, right? This is often referred to as tools in the OpenAI API spec. And it's a pretty simple interaction where your application will, start the process by calling the large language model, providing context of what are the functions it can call and under what context does it call them. Then as the model is achieving the prompt that you gave it, it decides whether or not it should respond by invoking the function call. The function, when it does decide that it needs to call the function is called, and the response of the return of the function, the response of the function is returned to the large language model, and then it keeps going until it fulfills the prompt. So for this, I think it's important to maybe start by looking at the architecture that was built to accomplish this task. There's a couple important pieces here. The first they'll talk about are the tools itself, right? And so remember, these tools are really just function calls. There's three that we created, one function call to analyze a project, another to write a file, and another one to make a scout recommendation. An important point to note is that each of these tools are encapsulated as runnable Docker containers. And they're all then registered with the large language model as a tool to call under certain contexts. The other aspect that's important are the system prompts. Now, these are additional context that's fed into a large language model. And what this does is it dramatically improves the output of that large language model because it encapsulates a lot of the best practices of how to create Docker files. There's also a large language model with an OpenAI API compatible interface for running inference. And then there's a client, and the client is actually plays a fairly simple role here because it just needs to start the process. Now, this all was able to be accomplished. This architecture was able to accomplish the goal. And I'm going to walk through the conversation loop that happened between all the systems involved here, because there's some very interesting takeaways that happen when you walk through it. So let's go through step by step in how this was executed. All right, the first part is a system prompt, right? Letting the assistant the being fed into the large language model, which tells the assistant that it's a specialist in writing Docker files, and because of that, it should be pretty definitive about the recommendations it makes, giving the model a little bit of personality to start with. And now the user begins this process with that first prompt, right? And the first prompt being to analyze the project to determine how it should be built. And then once that analysis is complete, you're going to create a Docker file to build the project. Now, this is the first key takeaway I have when looking at how to accomplish the goal, and that is one of decomposition, right? Now, the goal that we have is to create a usable Docker file without a human in the loop. That's not the prompt we give the large language model. Instead, we decompose the problem into its two important steps, which is, okay, well, if I want to write a Docker file, I need to know what kind of project it is that I'm writing a Docker file for. And then once that analysis is done, then you can build the Docker file. So decomposing the problem into its subcomponents, really important step. And so because of that prompt, we move on. The large language model responds back first with a function call. Because I told it to analyze I said the first step is always analyze the project. It will then return back with a call to a function. So the our client receives that and invokes the function automatically, and it says this is an npm project, right? It looks for certain files in the project and it lets it know what it is. That's great. The response then gets fed into the large language model that it's an npm project, and another system prompt kicks in. And this system prompt contains encapsulates all those best practices for how to build Docker files. It's important to dive a little deeper into what those best practices contain. Right, remember, this is defined by us up front, and it's useful for generating any Docker file. But it really is it's talking about what are the best practices for writing an npm project, and it has some pretty complex things in here that are really best practices that we've learned over many years of writing npm Docker files. Things around what kind of flags to use, how to run a multi-stage build, and then it even has instructions in here about calling Docker Scout in order to get recommended tags to use, or recommended versions of images to use as a dependency. So this is that other really key takeaway, is that these system prompts are used to encapsulate knowledge that you've built up over the years, so that every time you invoke the large language model, you're getting the best output possible, and not just throwaway output that eventually has to be rewritten anyway. All right, back to the conversation. So the system prompt had all the best practices in it, and because that best practice did include a recommendation, an instruction to use Scout under certain circumstances to call that function, then that's exactly what happens. It returns back with, okay, first I need to call a function to get a Docker Scout tag recommendation. Function call happens, and it returns back a recommendation to use that particular image tag. With that in hand, now the large language model can generate the Docker file and do the last step, which is to write the file. And so it's making another function call where the body of the file is the Docker file to write, and it's going to call our function write files. Great. Now, function call happens to write the file, but an error happens. This doesn't happen all the time, but in a couple cases that we noticed, it executed an error. Now you think, and this error was because of a syntax error with the JSON file. You might think that it would just end right there, but what's very interesting is what happens next. In that, that the response from that function call is returned to the large language model, and so it says, "Look, I'm sorry, I didn't mean to make an error. Let me try it again." Reformats the JSON file, calls write file again. This time it's successful, and it actually wrote the Docker file following all the best practices. This is another key takeaway here. The fact that it was able to, first of all, experience an error means that sandboxing those function calls using containers really important to limit the blast radius of any error that happens. But also the reliability of this whole kind of an architecture is really key so that it can rerun failures and recover. At the end, though, going back to the conversation, it figures out that it wrote the Docker file, the goal was achieved, and the conversation ends. So to summarize some of those key takeaways that we found while sort of building out this system and accomplishing that goal. Number one, the prompts really do encapsulate all that domain knowledge that you've built up over the years. By doing that, you dramatically improve the output of the large language model. We also saw how containers play a critical role in building a system like this because it really creates that sandbox environment, enabling you to be very flexible in your deployment, but also secure and limiting any blast radius of any issues that might happen. We also saw how decomposition is really key and how you have to really break down the problem into its subcomponents in order to have the goal accomplished in the way that it should. Those components that we broke it down into were the different function calls that would generally happen, as well as the prompt and instructions to the LLM. And then finally, we saw how important reliability is because mistakes are going to happen. I mean, humans make mistakes, and so do these agentic workflows. They have to be able to recover from them. But I think it's amazing to see that it is able to recover. Okay, so that was a lot. We covered a lot. Just to recap, we covered a couple different challenges and opportunities in the GenAI landscape. First challenge was around discovery and helping developers sift through the massive landscape of tools available to them. We showed how Docker Hub helps you do that with our brand new experience around the GenAI catalog. We also talked about the challenge developers face with the steep learning curve when they do find that technology or framework or service to use. And it's really hard for engineers to understand what those new technologies are, and we're helping them get past that learning curve and learn things quicker through our Docker Desktop feature set and the integration with the NVIDIA Workbench, as well as through the availability of Docker Compose stacks that just help you get up and running really quickly, abstracting away a lot of the complexity. We also saw how the opportunity that's created by the existence of Copilot technologies and coding assistants, and how that can drastically reduce the amount of time spent on getting up to speed with different technologies and just removing a lot of the toil from the developer workflow. We saw how Docker has created the the Docker extension for GitHub Copilot that's helping many developers uh, write their Docker files, write their Docker Compose files, and just learn about how to containerize their applications very quickly. And then finally, we saw how new types of non-deterministic applications are being built using agentic workflows, and how containers are playing a critical role in defining the architectures of the future. So before I leave you, I want to leave you with some ways that you can get started and engage with a lot of this material that we went over today. You can find that link to our GenAI Lab series that goes into many more examples of how to use GenAI technology to build new types of applications. You have a link there to our GenAI catalog on Docker Hub. And then you have a link to the GitHub Copilot extension that you can start playing with now. Love for you to engage with all of these. Get in touch with us, send us feedback. We love hearing all of it. And I just want to say thanks again to GitCon for doing this and for all of you for paying attention. Looking forward to connecting over LinkedIn and any other place. Please don't hesitate to reach out.